So here's a case study on search behavior. This is for a large online media customer of Aster's. The basic objective was to be able to improve search quality by understanding how their users were actually searching and provide more relevant searches, as well as provide more relevant content in terms of the search results to improve the overall customer experience. In the past, this particular account couldn't do it very easily. They had to do it outside of the database. They had to transfer data from the database to some mid-tier application and then run it in a silo in a single server environment, and then go through multiple custom aggregate functions that were written in a completely different language than standard SQL. Extremely tedious, time-consuming because of the latency of transfer, and it was completely non-parallelized. Using Aster, they were able to develop a much better solution via nPath. nPath is a SQL-MR function that provides sequential pattern analysis over large data sets. It allows you to be able to find interesting patterns by developing a set of regular expression pattern matches. It also allows you to do time series analytics, which is very difficult to do in a traditional database. Here's an example or snippet of the code where, as you can see, nPath is a SQL-MR function, and it's wrapped completely within ANSI standard SQL. In this case, the nPath function is being invoked on the input data, which is search tracking, and defining a pattern here, which is A, B, C, D, E. What this means is this is a regular expression that tries to match a particular pattern where, as an example, the first page could be a home page followed by a search result page followed by a profile page, or it could be a home page followed by a search result page 1, followed by search result page 2, followed by search result page 3, followed by the profile, either a product profile or user profile that the user is trying to search for. So there are multiple combinations, and A.B.C.E, D.E essentially is a pattern, and the focus or intent of nPath is to be able to isolate and identify all possible patterns that match this particular regular expression. After accumulating that data, the objective is to be able to do a count or some aggregation to sum up how often these patterns occur, and then be able to do some additional post-processing and MapReduce functions to be able to identify and provide a graph on the distribution analysis or distribution of search across all users. So in fact, the output of this is a distribution analysis output. Graphically, what this may look like is you can understand all of the different end nodes. You can see a home page where a user may go from a home page to a profile and then exit the site. They may go from a home page to the first search results page, then maybe view a product or user profile and then exit, or potentially start a new search. They may go to the second page. They may go to n number of pages. The benefit of this nPath is that by executing that analysis, you can actually see the distribution at the end, where you can see a distribution of what ratio of all users that started on a particular page, for example, the home page, what their downstream distribution is. And this is extremely powerful in order to understand how relevant the search results are and how useful the overall content is that's displayed to the user in the search results. As an example, if it's a case where you see 80-90% of users that started on a home page going to page 10 or search result 10, then it's probably an indication that the search algorithms need to be improved in order to provide more relevant search or more relevant content up front, so that the user can actually find the profile page more quickly and more easily, in order to ensure that the user has a terrific experience via search.